Today we shall see about deadlock. What do we mean by deadlock? Say for example, assume that we have two processes, process P1 and process P2, and two resources A and B in the system. Now, for process P1 to execute, it can complete its execution only if both the resources A and B are given to process P1. Similarly, for process P2 to complete its execution, it requires the same resources A and B to complete its execution. But note that the resources can be released. The resources can be released by a process only after its execution. That is, if process P1 is allocated with both the resources A and B, it is going to release or give back this resource only if the completion is completed. Only after completing its execution, it is going to release. Now, say suppose we have the resource A, resource B and two processes. Assume that process P1 is having or acquired resource A and process P2 has acquired resource B at some point of time. I repeat, process P1, the system has allocated resource A to process P1 and resource B to process P2. Now, as we have seen here, for process P1 to complete, it requires A and B, both the resources. Now what happens? P1 is having A, but it is going to wait for resource B. In turn, this B resource is acquired by P2 process. But if you see here, in order to complete the execution of process P2, even resource A is required. So now P2 is acquiring or it is holding the resource B and waiting for resource A, which is to be released by process P1. Similarly, process P1 has A and it is waiting for B, which should be released by process P2. Like this, it keeps on waiting until the resource is released by either of the process. This is the concept of your deadlock concept. Now, in order to overcome this, the operating system should allocate the resources in certain order or in certain sequence. The resources must be given in certain sequence. That is, each process should first request for the resource. After requesting for the resource, once the resource is allocated based on the request of the process, it should use that resource. To complete its execution. After completing the execution, then it should release that resource. So this is the important sequence to be followed by any of the processes which wants to execute its process in the CPU. So now we shall see what is the formal definition of deadlock. A set of processes is said to be in deadlock whenever process in the set waits for an event that can only be caused by another process in the set. I repeat, a set of processes, that is, processes are P1 and P2. Example, P1 and P2. It is said to be in deadlock. When every process in the set waits for an event, that is, the event is B here. That is your resource. It is waiting, process P1 is waiting for the resource to be released. That can only be caused by another process in the set. That is, only when the process P2 is going to release this particular resource, the process P1 can execute. So the event is resource B, which is to be released by process P2 for completing its execution. So such definition or such sequence is called as your deadlock definition. Next, in order to see to that the deadlock is met, there are four necessary conditions. A deadlock situation can arise in the following four conditions. Deadlock can arise in following situations. The first one is mutual exclusion, second one is hold and wait, third one is no preemption, and circular wait. Now, what is this mutual exclusion? What is this mutual exclusion? Mutual exclusion is nothing but it is a condition where at least one resource must be held in a non-shareable mode. Non-shareable mode, that is, only one process at a time can use the resource. Only one process at a time can use the resource. Only one process at a time can use the resource. If another process requests that resource, the requesting process must be delayed until the resource has been released. That is, at a time, a resource should be used only by one process. If the same resource is asked again by another process, that process needs to wait or delayed or wait until the resource is released. Until the resource is released. That is the mutual exclusive condition. Next, second one is hold and wait condition. Hold and wait condition. That is, a process must be holding at least one resource, and waiting to acquire additional resource that are currently being held by other process. That is, as we have seen here in the previous example, process P1 requires A and B to execute. P1 is holding A. Here P1 is holding A and waiting for resource B. It is waiting for resource B. Similarly, P2 is holding B and waiting for A. So such condition is called as hold and wait condition. Next, no preemption. No preemption means that resources cannot be preempted. That is, a resource can be released only voluntarily by the process holding it after the completion is executed. After the process has completed its execution. I repeat, no preemption means you cannot forcibly ask the process to release the resource. The process should release the resource voluntarily. Next, circular wait condition. Last condition to be satisfied to tell that it is in a deadlock. Circular wait is nothing but an extension of hold and wait condition. Circular wait is nothing but a set of processes, that is P0, P1, P2 up to Pn processes. Waiting processes must exist such that P0 is waiting for a resource which is held by P1, and P1 is waiting for a resource held by P2, and P2 in turn resource with respect to P3, and so on up to Pn-1 waiting for a resource which is being held by Pn, and Pn is waiting for the resource which is held by P0. That is, a circular wait condition is happening. So such condition is called as circular wait condition. So now the best example to see this, or to see all these four conditions are met, is an example what I have written here. Consider this as a road wherein the vehicles are moving in all the four directions: north, south, east and west direction. Now, in order to see this, first if we see mutual exclusion tells that only one process at a time can use the resource. Assume that all these things are junctions. All these points are called as junctions, wherein in this junction you should see to that only one process can use the resource. That is, at a time only one process can use the resource. That is, at a time only one vehicle in one direction should move. Next, here if you see here, you cannot have this. Next, hold and wait condition. A process must be holding at least one resource and waiting to acquire the additional resource that currently being held by other process. That is this junction can hold the traffic. Here, if you see here, as the vehicles are moving in this direction, since the traffic is jammed here, the vehicles have been held here. So it is waiting for this particular vehicle to move, which is in red direction. If this vehicle moves, then this can move further. So again, hold and wait condition is being satisfied here. The traffic is being held in this particular junction. Next, no preemption. Resources cannot be preempted. Resources cannot be preempted. That is, you cannot preempt any of the cars or your vehicles until and unless it is voluntarily moved. So again, here also no preemption is satisfied. Since hold and wait is satisfied, extension of circular wait, that is, extension of hold and wait is your circular wait condition. So once the junction is being held here, if you see here, it is in a circular fashion. It cannot move, this cannot move, this cannot move until the one resource is being released here. So now, in order to break these necessary conditions, what I can do is, first, as I told, mutual exclusion condition. Only one process can execute at a time. It can hold the resource and execute at a time. So what I can do here, I can have a flyover. I can build a flyover at this point and ask the vehicles to move on the flyover. Ask the vehicles to move on the flyover so that my mutual exclusion condition is broken down. It is being broken down. Next, how to break down your hold and wait condition? I can break the hold and wait condition by seeing that or telling that this particular junction can hold the traffic. This particular junction can hold the traffic only if this particular junction is free. Then only my hold and wait condition will be false. Next, no preemption. Forcibly I will try. No preemption means voluntarily the resource should be released. So in order to break this condition, what I will do, voluntarily I will pick up some cars and make space for that particular area to move, to ask other vehicles to move. Now I can also break my no preemption. Since I have already broken your hold and wait condition, circular wait condition also will be false. So this is how, or this is the best example to understand the deadlock situation.